Hello to everyone. I'm so happy to be here. First of all, I would like to thank Never Knows Better, Creative Code Art, Erin, X, and all the people involved in this event. And also, before starting workshop, I would like to introduce myself a little bit. My name is Pablo Alvarez. I studied electronic engineering and worked for industrial companies for several years until I started with two close friends, Vitam Studio 6 years ago, here in Valencia, Spain. Here you can see some of the work we've been working on for the past years. And since we started, we've been working in interactive installations, both for artistic and commercial purposes all over the world. And in this workshop, I'd like to share with you the workflow we are following to create our upcoming installation that's based in interactive digital living organisms. Okay, these organisms will react to different sensors like temperature sensors, biometric sensors, cameras, lip motion. So I'll show you the first preview. Okay, this first digital organism is controlled using a lip motion, where you can see that I control a sphere that will control the deformation of the spikes. And we were inspired by the jellyfish and the urchin, and also played with the bioluminescence of some organisms. And okay, let's get started. Let's start from scratch. I use blank network, and let's start from the beginning. Okay, first it's very important to understand the shape, and then try to separate the shape into smaller shapes, and then put it all together at the end in the render. So the first part we're going to do to start building are the spikes. The spikes are the most important part of the shape, and we have to really try to program a very smooth and organic spikes moving randomly. So let's start. It's very good to have a constant chop in order to keep track of global variables. I'll change the name to global, and we will leave it here, and then we'll add a lot of variables when we need them. Okay, so the first thing we need is a tube sub. The tube sub is, all of the spikes are going to be tubes, and here in the tube we have three important parameters: height and both radius. So let's add those parameters here: spikes height. That's one, spikes radius 1, and spikes radius 2. Okay, we can put this value and then change it. Okay, so now we have to reference all the values, like spike height, radius 1 and radius 2. Okay, now we have a regular tube but not a spike, so we need to lower down a little bit the radius 1, maybe to 0.01. Okay, it's important not to have 0, because if you have 0 you have a very nice looking spike, but we don't have any caps at the top. Oh, now we don't have at the bottom too, so I have to enable them. That's in the second tab, end caps, and now we have the caps. And it's important because afterwards, when we have all the render, if we have like a small radius at the top, we can see the light bouncing in the cap, and that's quite nice. So a very small top radius, and we can see the cap. Okay, after this we can add a null before geometry, and this is the geo that's going to be rendered. So we need a render pipeline. That's always the same for me. It's render light. Okay, and we can use also a normal camera, but for this example I prefer to use the arc-ball camera that's in the palette. So I'll get rid of this camera, go inside, cut the camera, and then okay. So now we have the render, we have the geo, we have the lights. Get more space here. Okay, and then if we go up a level, we can see nothing here. So that's because we need operator. Oh, sorry, and we need a null and out here, and now we can see it. Even if default viewer is better because I have black. Okay, I'll change this to be 1 full HD. If you don't have the commercial version, the maximum is 1280 pixels, so I'll stay with that. Okay, with an HD resolution. And then also we have to toggle the middle and the right, because what we want is to have zoom, translation, and also rotation with the mouse. Okay. Then we can split our view, get the panel, and now we have it. You can see if I rotate, now I'm missing the tube, and that's because we have the light in the opposite position as the camera. So a good thing to do is maybe to parent them, so now the light will be always at the back of the camera. Maybe it's too far away. Okay, and now sorry, panel, and now if I rotate, I have always the geometry with lights. Okay, perfect. Now what we want to do is to do the deformation, to bend the tube. So what we need is to have a bending deformation in order to move like this. So I think that this could be also done using subs, but it will be really expensive for the computer. So the best thing to do is to work with vertex shaders. So let's do it. And the vertex shaders in TouchDesigner, you can work with them using the mats. There's a GLSL mat, but this one is empty. You have to write everything from scratch. That's not what we want. So let's get a font. Okay, and the font material and the PBR material in TouchDesigner have this output shader button, and when you press this output shader, it will get the same setup you had in the material, but with the shader. So it's really helpful for this GLSL programming. Okay, so we can add, for example, a constant. Okay, we can load down the resolution to 1:1. It's just going to be the color, and then, for example, we can get this value, and okay, reference the value or the diffuse, and here if I change the value, I can change the color. Okay, and then I output the shader. Okay, now I can get rid of this one. You can see that everything is the same. We have the diffuse color parameters in the vertex shader, and we are ready to go. Okay, this is not going to be a GLSL tutorial or GLSL workshop. There's a lot of information on internet, YouTube, and the TouchDesigner derivative website. And I highly recommend Vincent Howe's workshop about GLSL shaders. In that workshop, Vincent also talks about the deformation I'm going to program here in the GLSL, but I think that his approach is kind of different, but at the end the result is the same. So please, you can watch, if you can watch that workshop, will be great to really understand how the GLSL pipeline works. Okay, the geometry sends all the information to the vertex shader, the vertices and normals, and then the vertex shader outs some parameters that the pixel shader grab and do the coloring and all the texturing and things. And here we have an info dat where we can see the errors we are writing in the code, and with this info we can like debug and see what's happening with the shader. Okay. Another thing I want to point out is that it's very important to have an external editor, a code editor. I'm using right now Visual Studio Code, but you can use Sublime or any other editor. Okay, I'll move this because we want to see everything. Okay. In here we can see the vertex shader. We have some uniforms. Uniforms are all the variables of the vertex shader. We can write the variables here in the vectors page. Now we can see that the diffuse color, it's already set up with the constant values. Then we have the main, where everything is going to be written. We are going to write here all of our code, and then we send to the world space positions the formation of the P, that are the points position, and also the world space norms with the N, that are the normals. Okay, so we are ready to go. It's important to, oh sorry, this is not this one. One moment, let me do it again. Okay. Okay. Oh, sorry. Okay, let's go. First, what we need to do is to have another variable called new pos equals p. P are the initial position, so we want not to deform them. We want to pass the values to a new pos and then do all the calculations in new pos. Okay, so now we change here a new position, and if we save it, there's no error. If I did a mistake, spelling mistake, we'll see an error here. Okay, sorry, because I want to put this in the geo to material. And now we have an error, and we can see here that undefined variable new po. So if we add ds new pos, we have the geometry again. Okay, so now we have the position. So I'm going to show a little bit how this works. If I multiply the position via value in integer, what I'm going to do is to scale the tube. If I add a value, not 3 because it's going to be far away, I'm going to translate it. Now it's because this one is, I'll reset the camera for you to see. Now we can see that our geometry is at the 1 1 1 from each unit, like +1 in x, +1 in y, and +1 in z. And we can also change just one of the axes. For example, new pos.x times equal 4. Now we are going to scale just the x axis of the geometry. Okay. Okay, in this example we don't want neither to translate nor to scale. We just want to bend, so it's a rotation we have to do here. So what we need is at the bottom to have a 0 rotation, because it's going to be attached to the body, and at the top we'll need to have maximum rotation. Okay, so for that we have a TouchDesigner function that's called td rotate. So new pos is equal to td rotate. I have to specify the index. In this case I'm going to rotate in C, and the values in radians, so 0.8 maybe, and let's see. Oh, td rotate new pos, oh sorry, times. Okay, so now we can see that we have a rotation in the z-axis, but a rotation of the full geometry, and we don't want that because we want, as I said before, we want to have no rotation here and to have maximum rotation at the top. So what I can do is multiply this by new pos.y, because our tube is in the y-axis, so this value will be smaller than this value. Okay, so now if we can see, we have like a horn, but we want the spike. Okay, what's going on here? Now what we have is the maximum rotation, the positive maximum rotation at the top. We have zero rotation in the middle and a maximum negative rotation at the bottom. If I like put this to 1.5, we'll have strong bending. And what we also can see is that the resolution of the geo is not very smooth, so we need to increase the rows of the tube. Okay, so let's do everything. First of all, what we need to do is to add it's small. Okay, let's add more values here, like spikes rows and spikes calls. Okay, so we had 10, now I need 20, and this we had 40, but with 20 is okay. And just reference spike rows in the detail. Okay, chop reference and chop reference. Okay, so now we have a much more smoother geometry. Okay, and also one thing we need to do is to change the anchor of the geometry, because now we have in 0.5s in the middle, so we need to be 1, and now it's okay. We have the 0 without bending and full rotation. Okay, we can see that now this is very high, so maybe 0.8. Okay, this is a nice looking spike, but it's static. So what we are going to do is we're going to add a dynamic variable and move the bending following that speed or that dynamic value. Okay, so I'll add in the vectors page, I'll add a variable called uniform time, and we will write the Python expression uptime dot seconds times 0.1, for example. What we need to do always is to declare the variable, so on uniforms, and I'll declare a uniform float. This one is going to be, uniform float utime, and what we can do is multiply utime. Now we see that this is going to be always growing and growing and growing and growing, because this value is always going up. So if we add a sine function, it will be like a pendulum, so it will go one way and another. Okay, I think that the speed is very low, so instead of changing every time here, what I can do is to add here a speed constant, maybe 0.8, and in the vectors page we can multiply my operator global times dot no, and here the name of the channel, speed. Okay, now it's moving faster. And yeah, now we have the spike moving around. Okay, before going any further, I would like to show you a very important resource from Matthew Ragan. Here we have matthewragan.com/TouchDesigner GLSL cheat sheet. Here we have a lot of resources for rotation metrics, remap, and what we need now is a vertex stage normal recalculation. I'm not going to explain all the code. You can look it by yourself and try to understand it. It's easy to understand and very important, because it does a very good normal recalculation because maybe if we are deforming it and we can have some normal problems, so it's better to add this code in our GLSL. Okay, so we'll copy that code and we'll paste it everything in the main, on top of the main. Okay, now we have it, and there are three parts. One is the get tangent basis, apply deformation, that's where everything is going to happen. Here we're going to deform our geometry, and then compute vert norm, where they are going to compute the vertex normals. Okay, so what we need to do is we need to add all the things we've already done to the deform page, deform function. Okay, so I'll change this name to new NP, sorry. You could leave new post, but for me it's easier to have NP in the apply deformation function, because I'm going to send here the new post, and this will be also new post np.y, and we have to add here again the vec3 new position. It will be equal to apply deformation, and we have to add two parameters, that will be p and n. Okay, and then we also need this thing, compute vert norm. I will be vec3 and new norm, it's equal to compute vert norm p dot n. Okay, okay, we have an error here. We can go to this thing, deform p. Sorry, that's because I'm sending this thing. Okay, now we have it. It looks the same, but we have to add here new norm. Okay, so we have a normal recalculation after the deformation. So now we are ready to go. Okay, the next step is to do an instancing, because we don't want to have just one spike. We want to have a lot of spikes around body or geometry. Okay, we will start using a grid here. We need to have the grid in the CX axis to be the floor, and then we have 20 by 20 division. So we are going to draw 400 points, so 400 primitives, and we want to draw each of the spikes in one of the points of the grid. So we'll add a null, we can call this null spikes instance. Okay, here we have the information of the instances. I'm going to change also the name of the geometry to geospikes, maybe geospikes. Okay, instancing is really easy in TouchDesigner, so we can just go to the instance tab, enable the instancing, and get the operator, and then p0, p1, and p2. Okay, so now we can see that we have 400 spikes. It's very little space, so I'll get this bigger, 4 times 4. Okay, now we can see that everything's smooth and 60 FPS, and we can go a little bit crazy with the instancing, maybe 100 and 100. Now we have 10,000 points, so we have 10,000 spikes. It's running at 60 FPS, and we can go like a little bit bigger space. Okay, this is not what we're going to build in this workshop, but it's nice to see that this could be like a grass field. If I put a smaller bottom radius, we have like a hairy style. Well, now every spike is moving with the same rotation and the same direction. That's why I'm only adding one rotation to every instance, so they are behaving all the same way. This is the next step. We are going to have different values for each one. We could do everything here in the GLSL, but it's easier for me to work with TouchDesigner. So I'll use noise chop. I could use also a noise stop, but sometimes it's easier for me to see the value of the different samples. It's easier for me to do it in chop, so I'll stay with that, but afterwards maybe I'll explain also how to do it in using tops. This one is going to be S noise 1, and let me change the name of the channel. Sorry, noise. And okay, we need to have the same number of instances than of samples. So now we have 10,000 because we are in the 100 times 100. We don't want this anymore. 20 by 20 is okay, and I'll go back to 2 maybe, or 3. Okay, and then we need this to be bigger because not 0.01 but 0.08. okay, what we need to do with this noise is to add the chop into the GLSL. We have to do this in the arrays page and just a uniform name. I'm going to call it snoise1, and the chop is this one, and it's very important to select texture buffer. Okay, now in our GLSL we have to declare the sampler, some space here, samplers, and then okay, uniform sampler buffer is nice one. Okay, now we have the uniform. Now we need to get the values, so we need to use a GLSL function called texelFetch. So I'll get Floyd noise 1. It's equal to texelFetch, and now we have to add the name of the sampler and the value we want to get, like for example the 1, 2, 3, 4, 5, 6, 7, 8 and ahead. We can use the TD instance ID, and this will get like the first one to the first one, second one, third one, to every of them. Oh, sorry, I forgot to add the samples here. Okay, what we need to do, as I said before, is to add the number of points to the number of samples. So in this, let's go to samples. We have 599. So I'll write a Python expression here. Operator, sorry, I have to open this for you to see. Operator, it's spikes instance dot num points. Okay, and we have to subtract 1 because now we have 400 samples, 400 points, because it's a zero based the zero count, so now we have 400. Okay, we have the texelFetch here. We can go like this, and okay, I'll multiply by the noise 1. An error, why narrowing type? Oh, sorry, I always forget this, is because I only need the x first value, the coordinate. Okay, now we have a noisy bending, a noisy deformation, but it's not quite noise because the period is very high, so we need a smaller period. Now we can see that the movement is more organic. And also the problem is that we are translating using the scene due time, so it will always be very same. I'll take this out. Now we have a static noise, and we can animate this using uptime.seconds. And remember, we have the speed variable, so global and then a speed channel. Okay, and now we can have the movement, and we can go here and the speed, put it faster and faster and faster. Okay, we don't need that fast. Okay, so now we have the all of the spikes moving around. This ray looks really nice. What I said before, if we lower down this, we can have like a hairy style. But for the spikes, I think it's better to have a bigger radius at the bottom. Okay, so now we have already noise for the Z position, the Z axis, and we have to add the other rotation because we don't want just to move in one direction, we want to move in two directions. An easy way to do it, but not very good, is to add here just like this a noise X also, and if I save it, we can see that everything moves in both directions. The problem is that, for example, each of the spikes is going to move always like the same way, because we're getting the same value for the X and Z rotation, and when it's positive one, it's going to be positive the other, so it will be like always the same. So because there's not a lot of time, I'll do the easiest way for everyone to understand. I'll just copy the noise. Now we have S noise 2, so I'll do the same procedure. Sorry, I'll add this as name. This is also the name of the job. Remember texture buffer. Okay, so now we have to add the uniform S noise 2 and add it also in apply deformation. We have to get another texel fetch. Also noise 2, and here also noise 2, and now noise 2. If I save it, there's no change because the noise is the same. So if I just change the seed, okay, yeah, we can now see that they are moving randomly. Okay, another important thing is that now we are multiplying the noise by the position of the y-axis. So if I put this like very big, the rotation will be crazy, and this is not what we want. So what we want is to kind of normalize the value. There are a lot of ways of doing it. For me, it's easy to control if I have the U height as a parameter, and this is going to be reference with this chop reference. Okay, and then I'll declare uniform U height. Okay, and then what we can do is to, this should be times U height, and here we can do the same, U height. Okay, so we need a bracket, an extra bracket here. Oh, U height and by multi token 12. Oh, sorry, uniform float, because I need to specify the value. Okay, now we have it. And now if I do this bigger, the movement will stay the same. Okay, in our preview we had an spheric shape, so let's, oh no, sorry, let's add a sphere here to change the grid. Okay, a sphere, and let's plug this into the instancing. Okay, now we have all the spikes instanced in the points of the sphere. And what we can see here is kind of a flower or another organic digital organism maybe, but this is not what we want. What we want is that the spikes are always facing the vector, the normal vector direction. So let's see, we want all of the spikes to be pointing and facing that direction. Here in the geometry, in the grid, we had the normals are all facing up, so that's why we had no problem. But now we have another issue here we have to solve. Okay, let's take this out. Okay, so what we need here is to rotate the spikes, and what we can do is that here we have an instance to page, we have rotate to vector order. So in here is where we are going to do the rotation. Okay, could be a little bit tricky if you don't do the rotation using the GLSL. Okay, so I found an easy solution. That's in the tube. We, instead of going to the y-axis, we go to the z-axis, and then we use the same instance operator for the translation. We can do here p0, p1, and p2. Okay, now we already have it. Okay, it's very important to change the rotate to vector order post-rod, because we need to do all the instancing and all this scaling instancing before the rotation. We'll see afterwards why. So post-rod would be the trick, and also we need to change here the anchors. We can put this in the middle again and change this to 1, because now we're working the z-axis. Okay, now we can see that all of the spikes are in the correct direction, but we need to change something in the GLSL, because now there's no movement. Okay, what we changed is the orientation of the spike, so we need to change this to be the Z, because now the Z is going to be the height. We can see here that now the spike is laying down. Okay, and also we have to change this rotation to be the Y rotation. Okay, and now if I save this, we can see that now we have the movement, the random movement of the spikes in a sphere. Okay, very nice. Maybe we have this too big. Let's do it a little bit smaller, 0.5. Okay. Now we already have all the rotation, so I can do this bigger, because now we're going to work with in the TouchDesigner network editor. Okay, now we have the one or more rotate to vectors is collinear with the vector. This is a warning because we need to change the orientation of the sphere. If I go z-axis, now we don't have the warning and it looks better. Okay. As I said at the beginning, it's very important to separate the shape into smaller shapes. So now we have the spikes. We don't have any coloring or any scale transformations, but let's continue to build the body, the interior part, because I don't want to see like the back, the bottom part of the spikes. Okay, so in this example, what I want to do is to get the same sphere. We are using 2 instances, and this will be the body, because then if I change the radius or I've changed any detail, it will change in both geometries. That's what we want. Okay, so we could do a select here, drag this one, so now we have the same geometry, add a null and add a geo. Okay, this geo, we can change the name to geo body, and now we can see that we already have this sphere, like the body, where all the spikes are their starting position is at the sphere. Okay, so we add a constant because we don't want to be that visible, so we'll add a constant material and then a constant top, because this will be the color, and black. I think that black will be really nice because we don't want to be very notorious, but we don't want to see the back of the spikes. Okay, so like this is perfect. Now that we have the interior, what we want to do is some coloring, because in the example I showed you before in my preview, what I had was a gradient of coloring that starts in black and goes until white. Okay, I started in black because my interior geometry is black, but it could be red, and should be from red to white, or from red to any color you want. Okay, I'll get another constant, because what I want to do is to have this to be the color. I don't want to change the diffuse, so I'll copy it and add here another variable that will be uColor. And now we have to grab the RGB values of the constant, so we have to write the Python expression of the operator color dot par from parameter color R will be the first value of the color, the red one, G and B, G and B, and then the last one should be alpha. I don't know if I'm going to use this value, but it's okay to write it down. Okay, I'm going to split this again, and okay, I have to declare this color uniform vec4 now, uColor. Okay, now we have everything here. For the coloring, we are now using this thing, overt.color equal to TD instance color. We are going to substitute this value for a color we are going to work with in the main. So first thing I need to do is to declare a vec4 iColor. It will be equals to TD instance color, CD times uColor. Okay, times uColor, and then we can change this and use iColor. Okay, now anything changed, because we are not we are just multiplying by the color white, so it's okay. So what we need to do is the same thing we did in the rotation. We need to increase the value of the color using np.c. So if I multiply this color by np.c, np, no, this should be new.c. Okay, very good. Now we have the gradient I wanted before. Okay, now we have a very good looking living organism, where we have a gradient that goes from the black of the body until the white of the cap. So we are getting it done. Okay, in my example I think I did a little bit different. Let's do it like that. What I did in my example is to change just the alpha value. So what we need here is times we need to multiply a vec4, and then we have a vec3 that is going to be the uColor dot xyz RGB. We can write also RGB is the same, comma new pos. See, that's the alpha. So now what we have is just the alpha is the one that's growing when following the height of the spikes. Okay, we now have the same problem we had before with the rotation. That it's not a problem if you want that effect, but if I increase this to 3, you can see that the rotation is quite the same, but it's oversaturated, the color. That's because I have the value going to 3, so if alpha is 3, it's like a very saturated value. So what I need to do is just do the same I did before. So if I add a new height and now I save it, if I put 3, okay, we have bigger and longer spikes, but the color stays normalized. Okay, let's go to 1, and we already have the coloring. We have the organic movement, and now all of the spikes are 1 unit in height. So what we want to do is to do like a more random scaling. So we can do it in GLSL. I think at the end we will be doing everything in GLSL, but for now it's much better to do it in normal TouchDesigner operators. I'll move this, okay, the instance here. I can get rid of the grid. Okay, and I'll put this a little bit behind, and just the camera and the lights to have all the geometry the same. It's good to use the color option here. I normally use red for the geometries, and maybe another color for the instancing, but it's not necessary in this example. Okay, now we are going to use tops for the instance instead of chops that we used before for the noise. So you can see another option. Okay, so we'll get a noise, and this noise should be the same resolution as the instance, the same that happened with the samples of the chop noise chop. So let's do it here in the resolution parameters. We will add we're going to get the values from the noise tree. Oh no, sorry, spikes instance dot numPoints times 1. Okay, I'll prefer to use 32-bit float, nearest pixel, and we'll leave this like this at the beginning. Okay, and add a null, and this is instance scale. Okay, let's go to the geo and to the first page of the instance, and we can grab this thing, and then in the Z, remember, we can use R. Okay, now we have a random scaling here. Look, if I mentioned before that it's very important to use post-rod, because if I use the default, it will do the scaling before the rotation. So there are some artifacts and wrong instancings. So post-rod, so we have this living organism already very random and very nice. Maybe we have too much amplitude on the, okay, if the offset is 0, we can put offset 1, and okay, I just work with it a little bit. I don't remember the parameters in my example, but you can go and the ones that you like. For example, here we have just no geometry because it's very small. That could be also very nice. Okay, so we have already the scale. In this example, using monochrome or not monochrome is not very important, because I'm just going to get one parameter, just the R or maybe the G. That depends on you. If it's monochrome, it will be the same. Okay. Okay. Now, before before going to talk about the interactive part. I don't know if we'll have time to cover everything. I'll put a little bit smaller the amplitude, and yeah, maybe the exponent like this. If not, there's a lot of difference. Okay, we'll continue with the shape. In the geometry, in the preview I showed you before, I had also some particles that were flying away the geometry, kind of like it's part of the organism. So I'll grab another select, because what I want to do is to spawn the particles using the same points as the instance, spikes instance. So the same as I said before with the body, if I change the radius of the sphere, will change everything. So that's really important. Okay, alt particles, and now if we see here, we can see that all the particles are being spawned in an order, going from like well, there's a lot, but 1 2 3 4 5 6 7 and in order. So what I want to do is to sort those points randomly. Okay, so we choose random, and now we can see that the points are spawning randomly. Okay, we go in a geometry. Okay, in my example, what I did was to use the particle as instance value of spheres. I'll do both things now. You can choose the one you prefer. Okay, here we can use the line material. Now we have an error here because it renders by default the lines, and we don't have any lines, so we need to toggle this off and add points. Okay, now we can see the points, but are very small and light here. That's because of the color of the far value. And maybe yes, I can change it because I want to, when they get near to the camera, to get darker. And what I want also is to the particle to fly away like a little bit faster. So an easy way to do it is to increase the mass, so they will fly away. We don't need that much. 100 is a lot, so I think that 30 will do the trick for this. And now we have random particles flying away from the geometry. Okay, the other option is to use a sphere. I'll use a transform because, and maybe a polygon with detail, very slow, very low detail. Okay, transform 0.01, and I'll render this thing, and I'll use a constant because, and here, and now I can instance particles, doing the same thing we did before, P0, P1, and P2. Okay, and now we have the spheres that if I put big spheres, not that big, but we have bigger spheres, and we can work with the spheres afterwards in a post process. This is one way of doing it. We can give both ways of doing it. Okay, this is a small network, so the FPS is not going to suffer a lot, but in big networks where we have a lot of geometries, and it's very nice to keep the viewer non-active. So if you grab everything and just leave like the important parameters, we don't need this to be seen anymore. And okay, now we have the out, but if we have it here, we can also take this out, and the FPS will be much better. Okay, now we have the interior part, we have the spikes, and we have all the particles. So let's work a little bit in the final rendering, and then we will talk a little bit of the interaction I did in my preview with the leap motion regarding the movement of the spikes and also the sound control. Okay. For the rendering, a lot of people ask me if I use SSAO. SSAO is like an ambient occlusion, system ambient occlusion. Okay, it's a very expensive operator, so sometimes it's good to use it, sometimes it's not good to use it. In the parameters, I always remove the blur. We need to this be full and crank this up. Okay, so what we can see is that there's not a lot of change, but yeah, if I get closer, you can see all the spikes have like an ambient occlusion. And if we play with the radius and also the contrast, we can get to a nice looking dark geo. Okay, so we'll use it, and we can, like, if we see that the FPS are going down, we can bypass it, and that's it. Okay, a good thing to do is that now the SSAO is working in the whole geometry, but we have here a constant material. Well, in the geobody we don't need it, and also we don't need to have SSAO in the particles. So we could add an operator, render pass, just get the geospikes, clear to camera buffer. So now we just have the spikes, and put this in the SSAO, and then composite everything together. Oh yeah, but I have to change here. Okay, I won't do this in this example because, but well, what I want to explain is that now if the problem is that I composite the render with this, we will add 2 times the spike, so it will be very saturated too. Let's see, composite, if we add this and this, we have double, so it's not what we want. And what I can do is to take from here the geospikes. So particles, no, we don't have this named, let's do it, particles, and render also. I want to geobody. Okay, geobody, and now we have the same we had before. Okay, so now we can leave this like that, render pass, SSAO, if we need it. If not, we can toggle it out, off, sorry. Okay, so now we have the composite. Another thing we can do with this is to get another render pass. Remember that the render pass can only be plugged to one render. If I put here, we have an error and say it can only be connected to one render pass. What we need is to connect this one. That will be fine, but I hate to have a lot of lines and springs going around, so I prefer to do like this. So now I prefer this connection line. Okay, in the render pass we just want to get the particles, so we clear camera, and what we want to do to the particles is to create a little bit of blur, because I want to simulate they are kind of light. So I'll add also a level and add to the geometry. Okay, if I increase the value of the blur and also increase the value of the brightness, we can see that we have like a glowing sphere around. Maybe it's too much, but we can see here we have the lightings are going around. Okay, perfect. We continue at 60 frames per second, and if we go to like maybe 40, we can also work with it. Okay, let's go back to 20 because it was quite good, maybe even 20 because I don't want that much spikes. Okay, and I think that maybe the particles are too big. Okay, let's put this in global. Particle size 0.01. Okay, and in the transform, source transform, sorry, in the transform, we could reference this top reference. Okay, so now we can control the size of the particles using this parameter 0.03. No, 0.1. Okay, perfect. Another thing I had in my preview was some God rays. I learned this technique, this very easy technique, thanks to Extas. Extas does a lot of tutorials and workshops in YouTube and in Patreon. So please follow Extas and watch his videos. Okay, so what I want to do now is to get another render pass. This render pass could be from render pass 1. No, we need render pass 2. Okay, and now we have just the particles, but we don't want the particles, we want the geospikes. Geospikes. Clear camera to buffer, that's okay. And we just need the white values. So there are a lot of ways of transforming this to white. Maybe we can use a threshold, and we already have everything white. We can use like this. That it's an option. Another thing we can do is a reorder. Okay, and all of the values to alpha. So any of the options is good. I think for this example it's better to hide the threshold because I'm not going to render the geometry, just need the white values of it. So I'll erase this one and go and add a radial blur. That's in image filters, radial blur. And okay, what radial blur does is blurs everything using radial, and we have some parameters here like the strength. Okay, and the center point, we can move it all around where the blur is facing. Okay, so for this example what we want is to start the radial blur over the top because we want to have this the God rays passing through the geometry. So okay, I'll just transform the top and move the geometry to the top left of the window. Okay, maybe that way, and change the center point. Should be also, wait a minute, go down, and the samples, okay, the samples 20 is okay, and the strength I think like that. Okay, after we can add a blur and a level and a level. Okay, let's move this a little bit. Okay, and now we have a level, and we can oh sorry, and we can composite everything. Just use add. Oh, sorry. Let's use add. Okay. It's very heavy, very noisy, so I will increase the blur and lower a little bit the opacity because I want like a radial blur but not very heavy. And this is very nice because when I move the geometry, or even if the geometry is moving, you can see the, let me this a little bit lower, you can see that the god rays are also moving. So what I said before is that I could use like white circle, a white circle. Let me do it, white circle, and move it to the side, and not transform, but just to the radial blur. Okay, now we have a circle, but the problem with this circle is that it's not going to move and it will be always static, so I think it's much better to have this geometry for the radial blur. Okay, perfect. Okay, now let's stop here a little bit because I'm going to take a break of 5 minutes and come back. Okay, we are back, and now we left the first part when we had a really nice looking organism with the god rays, the particles, and all the spikes moving around randomly. So now we are going to work with the interactive part. In this preview I used a lip motion. So first of all, I'm going to split the windows again. Let me try it, because with external monitor sometimes it's kind of tricky to split it. Okay, so now we are ready. So what we need to do is to have the sphere that I showed in the preview, and the distance of the sphere, the distance between the sphere and the different spikes will do the scaling and also the lighting. Okay, as I said, I'm going to use a lip motion. I created well, first of all, if you want to see, we have a lip motion top where I can see my hand moving around. I have to flip X because for me to control the sphere. Okay, so in the palette I have my own component that's called lip motion component, where I have my calibration and all the values. I think I have to go inside because I have to calibrate the C coordinate. Okay, this is going to minus 150 to 150 to 0 to 1, and then I'll need to add, I know I have to add here a math because the values I want to, instead of being from 0 to 1, I want the values go from minus 4 to 4. And also I'll add a lag because I really love to use the lag chop in order to have smooth movements. Okay, okay, now we have the lag, and you can see that the values are growing and changing smoothly. Okay, and then an out because I need the values. So, but we don't have to see this, and let's go. We add a null, and we can write here like lip motion control, so just the lip motion maybe. Okay, values. Okay, that's okay. First of all, what we want to do is to create a sphere. I'm sorry, to create a sphere, and we add a transform and then a geo. Okay. Now we cannot see the sphere because in the center point is in the middle, there is where our organism is living right now. So I'll do a little bit smaller. Okay, and then I have to control the translation of the sphere with the leap motion values. Okay, sorry. Okay, now when I move the hand around, we can see that we are also moving the sphere. Oh, sorry, I have to put first that we have to render also the sphere, and now we have there the little ball, and we can move it around, and it's going to move and follow my hand movements. Okay, let's reset the camera, and okay, have a good control of the sphere. Okay, the next step I need to do is to pass those values to the vertex shader, because I want to calculate the distance between the sphere and all of the spikes. We have to create a new uniform that I will call it U center, because the center of the sphere, and we'll pass the values to the uniform: tx, ty, and tz. Okay, okay, perfect. Let's go to the shader. We have to declare the uniform. It will be uniform vec3 u center, and then we need to calculate the distance from u center to all of the instance spikes. So there's a built-in function in GLSL that's called distance. So I'll have a float dist. It's equals to the distance between the u center, now the td instance and translate. We had before td instance id, we have td instance color, and now td instance translate, because we are talking about position and translation. And we'll calculate the distance to the u center, the position of the leap motion. And now we have the distance value. So if we now change the scale, the z scale, if we do np.z equals dist, okay, and with this we can see that when we get near the organism, the spikes length is smaller, and when we go like far away, the spikes grow. This is not what I did in my preview. I did the opposite. I had more calculations in the vertex shader, but I'm running out of time, so the best thing, the faster thing I could do is like just divide 1 times the distance. So now it's working like the preview example. If I get near, the spikes will grow, and if I go far from the organism, the spikes will get shorter. Now what I can see is that I have to limit a little bit that value. In my example, I used a map function, but here I would just limit with an if condition. So if the value of the distance is equal or greater than 1.5 or 1.3, the value of the distance will be 1.3. So there will limit the value to 1.3, so we don't have that very long spikes. Okay, so this is the we're getting at the end of the tutorial. We can see we can like lower a little bit the randomness of the period. We can work with for the scale. We can even erase the noise and the instant scale, or add a constant for having all the spikes with the same length. And okay, I'll pulse again to reset it, and then you can see that everything is being controlled with the leap motion. Okay, this is the end of the tutorial. Thank you very much for everyone that joined in. Thanks again to Never Knows Better, CodeArt, X, Erin, and everyone that's involved. And if you have any comments, doubts, or suggestions, please contact us in our Instagram or myself, Vitamin Studio or Pablo Alp. Here we can see again that I'm controlling the sphere and the spikes with the lip motion. So, okay, this is the end of the tutorial. Thank you very much.